eastern side of the Sierras, which creates an orographic effect on the eastern side of the mountain range. Due to the rain shadow effect, most of the state is desert or steppe topography. Generally, winter weather provides the western and south-central part of the state with most of its precipitation, which comes in the form of snow. Spring provides precipitation to the central and northeastern part of the state, and light precipitation occurs in the low western plateaus. Recorded annual precipitation varies across the state from less than 5 inches, 18 inches in Lamoille Canyon, increasing to 40 inches in the Sierra Nevada. Snowfall can be recorded up to 300 inches a season at higher elevations. These differences are caused by elevation and exposure to heavy precipitation storms over the mountains.
There are various types of rain gauges, which are devices that measure precipitation amounts. The amount, type, and frequency of precipitation are all factors that help hydrologists determine the proper rain gauge. One of the most common of rain gauges is the standard rain gauge. A funnel is attached to a 2 cm diameter graduated cylinder that fits inside a larger 20 by 50 cm cylinder. If the smaller cylinder inside fills up to its maximum capacity, the larger container catches the excess water. One of the benefits of using this type of gauge is that snow can be melted to see how much precipitation was attained.
A dipstick rain gauge is the preferred gauge used by NOAA in northern Nevada. The device is measured every 6 hours by hand. In order to measure the amount of rain, a special ruler is used, which is dipped into the gauge reservoir. The water in the gauge darkens the ruler up to the amount it rained. The tipping bucket rain gauge is very useful because it is automated. Rain collects at the top, then drains into a small hole at the bottom, which is then fed into a small apparatus that looks like 2 bucket ends stuck together. When 0.01 inches of rain falls into one side of the bucket, the side tips down to drain it out. The other side of the bucket then starts filling up with water until it reaches 0.01 inches. Each time the bucket tips, the tip is recorded. This type of rain gauge is good for seeing how much rain has fallen and how fast it was raining.
Measuring precipitation is measured in linear depth, normally in millimeters or inches. Daily measurements are usually taken at fixed observed times, normally 15 minutes to an hour, and should be read to the nearest 0.2 millimeters. Anything less than that is normally referred to as a trace. Precipitation measurements are exceptionally sensitive to gauge exposure, so measurements must be taken carefully to build a comprehensive station history and have available data for climate studies and research. Errors in measuring precipitation are very common, and in most cases, the actual amount may be less than the actual rain reaching the ground by 10 to 30%. Snow measurements are usually more prone to error than liquid precipitation. Nevertheless, it's necessary to make adjustments to the data in order to allow for errors before making the calculations. There are various errors that affect the true amount of precipitation, including error due to systematic wind field deformation, wetting loss, error loss due to the container being emptied, evaporation in higher climates, minute errors from splashing, and error due to blowing snow.
Another more technologically advanced method of measurement is the use of automated snowpack and climate sensors called snow-tell sites. These sites are mainly used to forecast yearly water supplies and to predict floods. Each site typically has a liquid precipitation gauge, an air temperature gauge, and pressure sensing pillows. These pillows are made of either a stainless steel envelope or a synthetic rubber filled with antifreeze solution. These pillows measure the snow water equivalent by recording the downward force exerted by the weight of the snow. Data is recorded and transmitted in real time using radio signals. It is interesting to note that rather than using an expensive satellite system, snow-tell signals are reflected off a band of ionized meteors between 50 and 75 miles above the Earth, then back down to one of the 2 polling stations in either Idaho or Utah.
Here we are going to show you how to make an inexpensive and effective rain gauge. You will need a 2-liter bottle, tape, a razor blade, a marker, and a ruler. First, mark 18 centimeters from the base of the bottle and mark the incision. Then make a straight cut with the razor blade. Invert the top portion of the bottle and insert it firmly into the base of the bottle. You can use tape or a clip to prevent separation of the 2 pieces due to high winds. It's now complete and ready to be mounted and tested.